In section 6.2, we talked about the properties of parallelograms. In section 6.3, our goal is to prove that quadrilaterals are parallelograms. So you'll be given a quadrilateral, some properties or some congruences, some parallels about that quadrilateral, and you need to use the properties of a parallelogram to decide whether that's enough information to say, yes, this is a parallelogram, otherwise, no, it's not. The 6 ways to prove that a quadrilateral is a parallelogram. The first one, and you need to make sure you write all of these down, keep the one heading, again, you're just writing down the bullets. The first one, if both sets of opposite sides are parallel, then by definition, that is a parallelogram. The second one, if both sets of opposite sides are congruent, then that's enough information to say, yes, it is a parallelogram. The third way is if you can show that both sets of opposite angles are congruent. Both of our opposite angles, the ones that are directly across from each other, make sure it's the entire angle, then it's a parallelogram. The fourth way, if the diagonals bisect each other, if the two diagonals cut each other in half, then it's a parallelogram. The fifth way, if one set of opposite sides are both parallel and congruent, then it's a parallelogram. And the sixth way, if one angle is supplementary to both its consecutive angles, then it's a parallelogram. So for that one, if I have one angle and I can prove that the angle consecutive to one direction is 180 with it and consecutive the other direction is 180 with it, then it's a parallelogram. So we're going to work through some examples. We'll determine if each quadrilateral is a parallelogram. In addition, if it's yes, we do need to state why. You need to know why it's a parallelogram. So the first example, number 1, says segment AB is parallel to segment DC. So AB and DC are parallel. I'm going to draw the arrows on. Remember, that does not mean the sides are congruent. It means that they're parallel. And AD and BC are parallel. So since I already used single arrows, I'm going to use double arrows. Looking back at our ways to prove if it's a parallelogram, the very first way, if both sets of opposite sides are parallel, then yes, it's a parallelogram. So by the definition, this is a parallelogram. So when I say yes, I need to give a reason. Yes, both sets of opposite sides are parallel. Okay, moving to the next problem. Remember, I no longer have the information from the first one. I'm going to move on to example 2. Example 2 says angle D, so this entire angle D, 3 and 4 together, is congruent to angle B, and that's the entire angle B, 7 and 8 together. I don't have any information on the other opposite angles, angle A and angle C, and since opposite angles must be both pairs, then I have to say no. I don't really have enough information on this one to say if it's a parallelogram, so then it's not. Example 3, same picture, and please make sure you draw this picture on your paper so that as we talk about these, you can see where the points are, where the numbered angles are. Number 3 says segment AE, so AE goes from here to here, I'm going to put a single slash, is congruent to segment CE. CE goes from the corner to the center, and I know it's the center because the two halves are congruent. Also, DE is congruent to BE. Because these are the diagonals and they're being cut in half, the two sides are congruent, then yes, this is a parallelogram. So if I look back at my ways to prove that it's a parallelogram, if the diagonals bisect each other, then it's a parallelogram. So when I write down yes, my reason is that diagonals bisect each other. Okay, moving to the next problem again, I'm going to erase the stuff from the previous problem. It's no longer true, and we'll move on to number 4. Angle D is congruent to angle B. Angle A is congruent to angle C. So I have D and B, which are opposite angles, congruent. A and C opposite angles are congruent. So number 4 I'm going to put yes, both pairs of opposite angles are congruent. And there's our answer for number 4. If you state that yes, it is a parallelogram, you must state the reason. So I know this is a parallelogram because both pairs of opposite angles are congruent. Number 5, AB, segment AB, which is our top segment, is congruent to DC, the bottom. Now, if I knew that the other opposite sides were congruent, then it would be a parallelogram. Or if I also knew that AB and DC were parallel, then it'd be a parallelogram. However, just having one pair of opposite sides is not enough information, so I have to say no. This one is not a parallelogram. Number 6, triangle ADC is congruent to triangle CBA. Now, we did talk in section 6.2 about the diagonals forming two congruent angles, but you really have to watch how these angles are formed, and you have to justify your reason with one of the 6 ways we talked about at the beginning. So I'm going to use the fact that these are congruent triangles to see if I can find some congruent parts. AD is the first 2 letters of my first triangle, so that side AD is the same as the first 2 letters of my second triangle, side CB. I also know that AB is the last 2 letters in my second triangle, is the same as CD, the last 2 letters of my first triangle. Therefore, I do have, based on what I know about congruent triangles, opposite sides congruent. So yes, this is a parallelogram because both pairs of opposite sides are congruent. And we'll continue to use your information you brought with you from the first half of geometry, what we know about congruent triangles, what we know about vertical angles. We'll use all of that information throughout the trimester. Number 7, AB is parallel, to DC. So I'm going to put the arrows on there. Those sides are parallel. And AD is congruent to BC. Okay, so I want to be careful because it's not the same side. If it was the same side, then I would know it's a parallelogram. So for this one, I have that these 2 are parallel. AD and BC are congruent. Well, I'm going to see if I can use my parallel lines. I know some things about parallel lines. I know if I have parallel lines, this would be my transversal that touches both of those, and I would have my alternate interior angles congruent. That doesn't really help me. Even if I try to look at this triangle that I'm outlining in blue, and I have an angle, the center side by reflexive and a side, we can't use angle side side, so I'm stuck. That's not enough information to do anything with, and no, this one is not a parallelogram. It must be either both pairs of opposite sides congruent, both pairs of opposite sides parallel, or one, the same pair that's both parallel and congruent. Number 8, triangle ADC and triangle ABC are congruent. Let's do what we did before and see if we can match up the corresponding congruent parts. Segment AD is the first 2 letters. That's congruent to AB, the first 2 letters. Segment DC, second and third letter, is congruent to segment BC, second and third letter. This makes consecutive sides congruent, but not opposite sides. So no, this one is not a parallelogram. Exact same picture. Make sure you have this picture drawn on your examples. Number 9, we have segment AD congruent to segment BC, and segment AD is parallel to segment BC. Now, if I go back up to my 6 ways to prove that parallelograms are congruent, the 5th one was if one set of opposite sides is both parallel and congruent, then it is a parallelogram. So going back to example 9, I have the same pair of sides, both parallel and congruent. So I'm going to put yes, and I must tell why. So I'm going to say opposite sides are both parallel. 2 lines are parallel. And you can use the symbol for congruent. So yes, that is a parallelogram. Number 10, I'm actually going to read through these and just mark these, and then we're going to do some other things with the picture. I know that angle 1 is congruent to angle 5. I also know that angle 2 is congruent to angle 6. Well, let's see if we can use what we know about congruent angles and parallel lines. If I have AB and DC, the line that touches those and forms the congruent angle 1 and 5, this would be like a transversal, and I know that 1 and 5 are congruent. Those are alternate interior angles. So by the alternate interior converse, I know that AB is parallel to CD. Then I can use AD and BC the same way. So I'm going to do another picture, AD and BC. And this segment DB works like the transversal. Hold on. Sorry, AD and BC. I apologize. This segment AC works like the transversal. Here's angle 2, and here's angle 6. I drew the wrong line in. Because that's the transversal is the line that touches both the sides and forms these two angles. Since those two are congruent, those are alternate interior angles, that is enough information to say that segment AD and segment BC are parallel. So using what I know about parallel lines, those are alternate interior angles, by the alternate interior converse, we can say that the sides are parallel. Then yes, this is a parallelogram. I'm going to put number 10 right above it because both pairs of opposite sides are parallel. So by definition, that will be a parallelogram, and that's one that's a little bit trickier. We need to watch for that. Those alternate interior angles being parallel, we can use the converse to show that the sides are parallel, and yes, it's a parallelogram. We'll be working on page 342 to 345, number 9 to 19, and then 45 through 47. We'll also work on handout 7B.